Hi, Haley. How are you today?
Hi, how are you?
You skills over the weekend or for
What did you say?
I apologize. There's apparently a huge lag right now. Hopefully- Just asking, scored big deals over the weekend or today?
Oh, I didn't really. My mom went shopping a little bit.
All right. How was it going back to school today? Was it rough or was it kind of okay?
It was okay. I still have a sub, so nothing really much.
Okay. Mom said you test upcoming later in the week. Um, you know what's going to be on the test.
Um, kind of. My teacher is gonna be here tomorrow, and she's gonna give us a review packet and stuff. And then all I have right now is the warm up which packet, which I'll send in just a second.
Perfect. Yeah, get that over and take a look at it.
Okay, I should be sent.
Got him. Load. Are the warm-ups generally a good indicator of what is on the test?
Yeah,
Okay,
pretty much.
let those load up. Not sure why my internet is so slow. If it is a problem, please let me know.
Okay.
There you go. Okay. Taking forever to upload. All right. Just zooming in on this first question here. With life, much is left. Oh boy. Okay. Um, no calculator. Okay, I see what they're doing here. Did you have any issues or questions about number one? Did you were you able to try that on your own or is that
I mean,
you know, group?
kinda. She did that one. The sub did that with us today, but
Okay.
I
So
just some of the logs confuse me.
yeah, there's no log in this particular problem. But you have what's called an initial amount. An initial means at time zero. So that's why you go to a table here. You have time and you have amount. So at time zero, there's 10 grams. Is that okay?
Yeah.
And the only thing you know now is that 9 days later, there's half. That's what a half-life means. Half means that it reduces to the half of what you had every 9 days. So in 18 days, it would be 2.5. So this number is what's going up by 9. This number on the right is what's divided by 2. So one more 9 gets you to 1.25. You're dividing by 2 again. And then one more 9, you're dividing by yet another 2. Now you could switch to fractions, which is what your teacher's doing here. Depending on your comfort level, you could also just keep going with decimals. Okay, let me give you a problem like this to try. So let's say it's a 40-gram sample. It has a half-life of 19 days. And after 95 days, how much is left? So do you want to give that a try for us, please?
So it'd be 2.5.
So let's take a look here. So T, and then you can call it Y or the amount, doesn't really matter, but at 0, it's 40, 19, it's 20, 38, it's 10, and then what'd you go? 57, it's 5, 76, it's 2.5, and then 95 is 1.25, something like that.
Oh, I meant to 76.
So now we can talk about logs. Have you talked at all about them since
Kind of, but the way that the sub did it, I didn't understand.
okay. Right. So Tuesday. So is the warm-ups, I'm sure I've asked this, I apologize if you're repeating yourself, but is this like what you start with in the class, or are you supposed to do it before you get to class?
Um, well, normally when she's there, we'll start it with her. Like she'll do it with us, or and then I mean I don't know. It kind of depends on the days. And then some days she'll just has us do it, and then she just collects it at the end of the week. So we're supposed to just do it daily, I guess, and then occasionally she'll review them at the beginning of class, and then we turn it in on Friday.
So I'm gonna write a few things. Log base 4 of 1 is 0. Log base 4 of 4 is 1. Log base 4 of 16 is 2. Now, do any of these like look familiar? It's like, oh yeah, I've seen that, or I know why that is that number. Any of this?
Um, Not really. We've been over that like the
Yeah.
log's just the exponent
Okay.
or whatever. One of the
So without knowing why this is, I want you to solve the following three equations, please. Sorry, this is 4, and this is 16. And this first one is 1. So I want you to solve each of these for x, please.
is it negative 4, 1, and 13. Or no,
Those,
negative 2.
sure, okay, so -2, I'll go with the first one. How about the second one?
1,
Okay, and the third one?
13.
Okay. All right, so now we're gonna make a table. All right, so we're gonna do X, Y, Y is this minus log X plus 3 plus 1. So we're gonna start with 1. So this becomes negative log 1 plus 3 plus 1. And again, without really, base 4, without really knowing, I'm sorry, why did I do that? I apologize. I'm a bit, what the right word is, tired. Tired from the weekend. Um, so let me reset here. So when you put the X value in, you get minus log base 4 of 1 plus 1. Go back to our reference here. What is log base 4 of 1? It's 0. 0 takes the place of that position. So it becomes minus 0 plus 1, which becomes just 1. Is that the part that doesn't make any sense? Like why this is the value that
Yeah.
it is? Okay.
So log 4 to the 1 equals 0, and like those three, will they always be like, are those like set? I don't know what the like word is.
Yeah, let me give you another example here because it's not really that important that we do this one. It's what I kind of heard because you'll do it tomorrow. Log base 3 of 1 is 0. Log base 3 of 3 is 1. Log base 3 of 9 is 2. And I'm going to write it slightly differently. Log base 3 of 3 to the 0 power equals 0. Log base 3 of 3 to the 1 power is 1. Log base 3 of 3 squared is 2. The exponents are what the result is of the logarithm. But sometimes it's easier as 1 or 3 or 9 or so on.
Okay.
All right. So that, like, to answer your question, it's like, well, you got to see the pattern, which is that if it's to the power of 0, it's 0. Power of 1, 1, power of 2, 2. Let me do another one here.
Okay.
Let's go log base 2 of 1, log base 2 of 2, log base 2 of 4. So if you were to rewrite these, it would be log base 2, 2 to the 0, log base 2, 2 to the 1, log base 2, 2 squared. What would the results be?
0, 1, and 2.
Okay. So now the next answer is not 3. I'm going to choose a large. 32 is 2 to what power?
The is it 16?
No, so like 2 to the power of 3 is 2 times 2 times 2, which is 8. So I'm asking you to figure out that number. Like it's not 16, that would be 16 twos, that would be very, very large. Trying not to give you the answer. Like go to the next one. Like what is 2 to the 4th? What is 8 doubled? Then what about when it's
Is it
doubled
2 to the
again?
4? Is it 2 times 32? Or 2 to the 30?
Okay, so here's what 2 to the 32 power means. 2 times 2 times 2 times 2 times 2. And there's
3.
32 of them. That's gonna be really large. We don't need to get that large. You just got to go up from here. Like, what's 2 to the 4? What's 2 to the 5? What's 2 to the 6? Like, you'll get the answer eventually.
Is it times 6?
So here's 2 to the 6. You can tell me if this is correct. 2 times 2 times 2 times 2 times 2 times 2. And you can break it up. Like you can do, 2 times 2 is 4, 4, 4. 3 twos is an 8, 8. You tell me, is that 32?
Yes. Wait.
Okay.
No, no, no.
4. Yeah.
It's
And
not.
so I'm really struggling here because like this is not a complicated thing. I just feel like you're not going like 2 to the 4, 2 times 2 times 2. 2 to the 5th is 2 2 times 2 times, you know, 2. This is too big. The 2 to the third is too small. It must be one of these. Which one is it?
2 to the 5th.
Okay. The reason we were doing all that is because what we've established is that when the base, that was kind of the missing link here. To see it. When the base matches the thing you're taking the log of, the answer is just the exponent.
So 5.
See how like match these match. Same with well, we didn't do that earlier. So that is the idea. So let's move to question 3A. Okay. Your goal here is to make the bases the same. And so you typically go from the larger to the smaller. So the game here is like, how can I make 25 into 5 to some power? That's what we're doing in the last problem. It's like 5 to what power is 25?
5.
And that's my question to you. To 5 to the 5th power is 5 times 5 times 5 times 5 times 5.
2.
5 squared. There you go. So this is 5 to the 2x minus 4. And this is key here. When the bases are the same, base is the same, that's the 5s, you set the exponents equal.
So it'd be
All right,
x
so you're
equals.
going to set 2x. Yeah, go ahead.
I
Sorry.
did 2x minus 4 equals 2. So x equals
Good.
3.
You got it. Very good. So I'd like to give you a couple of more problems like that, if that's okay, because that's the first type, and then we'll move to the next. Let's see if you see this style of problem.
It glitched.
Have you seen this type of problem a lot? This type here.
Um, I have not really seen any of those ones yet.
I do apologize for now that there's an issue, and I don't know if I can resolve it, but we shall see. Let me find a few more problems here. So here's one. So here's one for you to try. 9 to the 2x equals e to the x minus 6. This has a tiny little wrinkle in it, okay? And the tiny little wrinkle is 9 is really 3 to what power?
The third.
So 3 to the third is 3 times 3 times 3. Is that really is that really the answer?
No, it's just 3 squared.
Yes. So you're making that classic mistake where you think, okay, that is kind of true, but not exactly. When you exponent x, do you remember the rule for those?
I don't keep the.
You multiply them, so it becomes 3 to the 4x. So these multiply. All right, so now that equals 3 to the x minus 6. Now you're going to see the x equal use for x.
Can you just equal them together from that? From there.
You set the exponents equal. You write 4x equals x minus 6 because the bases are the same.
The x equals -2.
Are correct. Good. Okay, let me give you one to try on your own. And I can afford to ask questions, but so go ahead and solve for x, please.
The x equals -5.
Very good. Okay, so one other type of problem here to look at, and then we'll move back to your page there. We talked about the idea of making the larger base into the smaller. The second strategy is to change both bases. Okay, so like there's no way in this problem, there's no way to go from 27 to 9, even though it kind of looks like you can. All right, so that means we have to actually make both of these into a base. It's 3 and it's 3. What is 27 in terms of 3? 3 to what power?
Um, 9. 9 to the 3 would be 3.
Okay, so 9
Or
to the
no,
third power
a
is not.
power. I was
It's so easy to do what you did, and that's why I keep bringing this up because it's better to mess up now than on the test, of course.
um 3. Is it 3 to the third for 27?
Okay, good.
And then
Yep.
2 for 9.
Okay, and so and so it's an exponent, so it becomes 3 to the 3x power because apply. For the one on the right here, it's 2 times parentheses x minus 2. So now when you set those equal, you get 3x equals 2 times x minus 2. You distribute and solve for x, you get x equals -4. Any questions on that before I give you one to try?
No.
Yeah. All right. So what problem for you to try? You actually have options. I'll put both up you. There's only a few problems like this. You go to the sum power, or you can go to 4 the sum power. Leave it to you to decide which direction you want to go.
Okay.
But give this a please.
Okay. So the 4 to the third and 4 square.
Okay, that works. So keep going and solve for x, please.
Do I just do so? Do I do 2x plus 4 equals 5x, and then
From
solving?
here, we yeah, in the previous problem here, we multiplied the two exponents together. Because right now the bases are not the same, but now like down it's 3 the same. So in your problem, the answer is like these bases are not the same yet. But as soon as you multiply 3 times 2x plus 4 and 2 times 10x, then they are the same.
4, 6.
So to be more direct, you're going to take 3 and multiply by 2x plus 4, 2 times 5x equal to each other.
Okay. Then x equals 3.
Okay, so you have a 6x plus 12 equals 10x. Is that what you?
Yeah.
And then yeah, x equals 3. All right, very good. Okay, so I know that was a lot of diversion from like what's on your page, but the each of these, like letter B is, one type, letter C is kind of the same, but you got to know how to tackle them. So letter B here, you look at, say, well, can I make the base the same? Like, can I make 14 into 6? The answer is no. Can we make 6 and 14 into like a same base? And the answer is no. This is a new type of problem. Okay, and this is the one where you use natural logarithms. Have you seen that before?
Yeah, a little bit.
Okay, so you take the natural log of both sides of the equation. And so it doesn't look any better. It actually looks worse. Yeah, it's like, well, let it make any better. But there's a property here. The property says that the log of like x to the n is n times natural log of x. So that exponent comes out in front. So on the left here, this 3x minus 2 is going to come out in front. Now it's in parentheses, 3x plus 2 natural log of 6 equals natural log of 14. Is that okay so far now, what we did there?
Yes.
Okay. So what kind of like new, different for the students like this, you're like, what if this natural log of 6? It's a number. It's a representation of a number. Um, like if it were 5, you would know to either multiply in or divide by it. You do divide by here. You just get rid of it altogether. This becomes 3x minus 2 equals natural log of 14 over natural log of 6. So if you're okay with hearing up to this point, again, this is some sort of a number. Like it looks really complicated. It's really just a number. You don't look at that side though. You look at the side with the variable. You undo addition and subtraction first. You're going to add 2 to both sides. There's no 2, so you just leave it kind of hanging off to the side. Right, and then you divide everything by 3. So it looks really messy, looks really, but is and then sometimes they have you go to a calculator, except yours says no calculator. Oops. So take a look at the steps. Let's maybe just look at them one more time together, but maybe you will uh, um, see it's a pretty straightforward process. After you take the natural log, you bring the exponent out in front, you divide by the natural log both sides, and then you're solving this uh, uh, two-step equation here.
Where do you get +2 from? Oh, just that to get the x.
Yeah, undo. Yeah.
Okay.
So let's take a look at C. C is actually like one we just did here. So it'll have a lot of the same steps. All right. And then we'll maybe have you try a couple here. So the first thing is to divide by this -2. And now it's 6 to the x minus 3 power equals 7, which looks really, really similar to B. Like it's almost the exact same and meaning the same steps to solve. So what did we do first in B when what was the very first thing I said to do with both sides of the equation? go back up and look. What are we doing? What are we doing in this line right here? What right that's from the
ln, so natural log.
Ellen, yeah. Is the equation. Sometimes you just gotta understand what it means. From here, another question for you. What do we do with this exponent? What do we
Put it on
this
the
exponent here?
put it on the outside and on the other side in parentheses.
Yeah, out in front in parentheses. And from here, what did we do? Our goal is to get to x. How do we undo ln of log of 6?
Um, can't or make them a fraction.
You divide, yeah, you divide both sides by it. So you're left with x minus 3 equals natural log of 7 over natural log of 6. And then how do we undo the minus 3?
Adding 3 to both sides.
Adding 3 to both sides. And there's no, this is not meaningful. This isn't, you would then go to a calculator, except yours is very clearly no calculator. You don't simplify, you don't do anything else. You just leave it as is. It's kind of like solving what are called literal equations, which was like, ax plus pw equals q, and they would say to solve for x, and your answer was always messy. It was like, okay, q minus pw over a. Like, that's the nature of these. They just don't look nice. Okay, I'm gonna give you one to try here, please. Then we'll move to the other side of your page. All right, go ahead and solve for x, just like we've been doing.
So would it be x equals ln 12 over ln 6 minus 2?
Got it. Very good.
Does
Right.
the
Definitely got
12
that.
over the 6 simplify?
No, no.
Okay.
Yeah, I made that comment here. You just leave it messy.
Okay.
See, the danger is if you try to simplify and you do it wrong, there's a way to maybe change this, but if you do it wrong, it's worse than just leaving it messy.
Okay.
Might be a great question to ask your teacher. Yeah, once he gets back, show that, show some engagement in the in there. Okay. All right. All right. Calculator active. All right. I'm debating where to go from here. Um, it looks like you are going to really dive into logarithms this week. So I guess we can spend a little more time on this. This problem for Wednesday. Maybe it'll make more sense. Kind of look at something like this. We shall see. All right. So sketch the graph of f of x equals negative log base 2 of x plus 3 plus 4. So in the back, say, okay, I can only take log base 2 of 1, log base 2 of 2, log base 2 of 4, log base 2 of 8, and so on. And if you're wondering, like, where are those coming from? It's really log base 2 of 2 to the 0. But like, I don't think of 1 as 1. Log base 2 of 2 to the 1, log 2 of 2 squared, log base 2 of 2 cubed. Starting point. I apologize if you didn't hear much of that. This is your starting point. You'll have to, navigate this a little bit more in class the next few days. So the reason this is important is you're setting that inside part here, x plus 3 equal to 1, equal to 2, x plus 3, x plus 3 equal to 8. And then solve each of these for x. That's what's going in your table when you graph. So go ahead and solve each of these for x, please.
So is it -2, 1, or -2, -1, 1, and 5?
Yeah, so those are on the table. So you have x and you have y. Let me do it slightly differently here. So it's line log 2 x 3. Or so when you put -2 in, it becomes negative log base 2 of -2 plus 3 plus 4, which becomes negative log base 2 of 1 plus 4. So do you remember from our chart up above what this equals?
I don't. Is it?
So the 2 to the 1 is ends up being right. So so it ends up being 0 not there. So this part right here is 0. What is the net result? What is 0 plus 4?
4.
Okay. So now we do the same thing for the next, for -1 here. We have minus log base 2, -1 plus 3 plus 4. So it's negative log base 2 of 2 plus 4. You remember what this part is? Log base 2 of 2?
1.
It's 1. Goes with that negative, so it becomes -1 plus 4. What does that become?
Um, 3.
Should be 3, yeah. And so then we do it again. We do it for the next x value, negative log base 2 of 1 plus 3 plus 4.
So it'd be -2.
Yep, -2 plus 4, which is 2. You will notice a pattern that it goes down by 1 each time. And that will be useful when you try and graph it. I have no idea if this is how you'll see it in class. That's yeah, it's just the way I show it. Then you got to go through the graph and plot those points. And these things always have a certain shape to them. They kind of look like candy canes. But candy canes. 4, -1, 3, 1, 2. So this one, you'll learn about this later on, but this that kind of okay. All right, we're gonna go ahead and stop here for today.